This is Mrs. Ward, and I'm going to go over the classwork for section 4.5, part 1, where we're graphing the fifth graphs of sine and cosine. So let's just get started. The first one has the function as f of x is equal to 2 sine x 4x plus 1. So just, I like to write down my a, my b, my c, and my d. So my a is a number that's outside my trig function, so that's going to be 2. My b is a number that's in between, inside here with my trig function, that's going to be 4. My c is whatever I'm adding or subtracting inside this parenthesis, which in this case is nothing, so it's going to be a 0 since it's addition. And my d is whatever I'm adding outside the trig function, which is 1. And remember, this plus 1 can be in the front or it can be in the back. It doesn't really matter. So to find the period, I'm going to take 2 pi and divide it by my b, which in this case my b is 4, and I'm going to get a period of pi over 2. To find my step, I take my new period, which is pi over 2, and I divide that by 4, which is the same thing as multiplying by 1/4, and I get a step of pi over 8. The start, I take whatever is inside this parenthesis, so what this 4x, and I set that equal to 0. So I'm going to do that work down here. 4x is equal to 0, which means x is equal to 0, which means I'm going to start at 0. To find my end, I take that same 4x, and I set it equal to 2 pi, because that's the normal period for a sine curve, is between 0 and 2 pi. I divide that by 4, and I get x is equal to pi over 2. So my end is pi over 2. At this point, I like to start filling in my chart. So I have my start I set was 0, and I say that I'm going up by 1/8 or pi over 8 each time. So this is 1/8 pi over 8. Then the next step would be pi over 8 plus pi over 8, which would be 2 pi over 8, or in lowest terms would be pi over 4. Then 3 pi over 8. And then finally 4 pi over 8, and I can write that first if I want, which will be the same thing as pi over 2, which checks with what I said the end was going to be. My horizontal shift is whether I move left or right. In this case, it's going to be my start, so my horizontal shift is 0. My vertical shift, but later on, we should know that it's going to be, okay. The vertical shift is whatever I'm adding or subtracting, so it's my d, which in this case is going to be 1. And then the amplitude is my a, but it technically should be the absolute value of a. So, but in this case it's 2, so it's going to stay 2. Then I go up here and I identify which trig function I'm looking at. So here I'm looking at a sine, which determines what this pattern is going to be. So a sine curve starts at 0, and it goes 0, 1, 0, -1, 0. Then I'm going to follow the pattern that it says on the chart, but I need to know it because we don't give it 8 times the other quiz. So I am going to take a, which is 2, times this, so that'll be 0, 2, 0, 2 times -1 will be -2, and then 0 again. And the last thing I'm going to do is add my vertical shift, so I'm going to add this d. So 0 plus 1 is 1, 2 plus 1 is 3, 0 plus 1 is 1, -2 plus 1 would be a -1, and then 0 plus 1 is 1. Now when I come to my graph, if I think about this, the whole graph that it has right now is between 0 and pi over 2. So that whole graph is going to curve right here. Well, it's going to be very smushed, and that's not a very mathematical word, but that's what it's going to be. So I'm going to decide that I don't want to deal with it that small, and I'm going to change my scale. So what I'm going to do is I'm going to leave 0, 0, but I might make this, let's say I made this, say I made this pi over, I could make it pi over 8. Let's make it pi over 8. So then this would be 2 pi over 8 or pi over 4. This would be 3 pi over 8. And finally, this would be 4 pi over 8 or pi over 2. And then I'm going the same way down here. So I can change the scale if I want to make it more convenient for me to graph. But if I change the scale, then I have to identify how I'm changing the scale. And when I change the scale, you need to be careful that each line represents an equal distance. So in this case, so in that was it. So in each case, each line is 1/16 or half of it. So here, when I go to graph, I made this beautiful table, and I'm going to use this beautiful table that I created, but I'm going to only graph the first column and the last column. Everything else in between is what I call my work. So it's how I got to that is 1, 3, and 1. So I'm going to graph 0, 1, then pi over 8, 3, pi over 4, 1, 3 pi over 4, negative 1, and then finally pi over 2, 1. And when I have this curve, I go up, go down, and then I go back up again. Now I want to mirror it on the other side. So see how here's one of my max, and then I hit my midline, and then I'm going to hit my minimum, hit my midline again, hit my max again, and that is going to be my sine. Let's take it back, look at it, make sure it looks okay, and I think I did a pretty good job, so we're going to move on to the next one. The next one is a cosine function, and I'm again going to identify my A, my B, my C, and my D. So my A is a number that's out front of the trig function, which is going to be 3. My B is a number that's inside the parentheses with the x, so in this case it's going to be 2. My C is whatever I'm subtracting. So this technically, remember, it's bx minus c. So I'm technically have this 2x minus a negative pi over 2. So this c is going to be a negative pi over 2. And then my d is whatever I'm adding or subtracting on the outside, and I don't have anything on the outside that trig function, so it's going to be understood to be 0. Now when I find my period, I am going to take 2 pi and divide it by my b, which in this case is 2, and I'm going to end up with a period of pi. To find my step, I take this new period and divide it by 4, so that's just going to be written as pi over 4. To find my start, I take whatever is inside this parenthesis, and I set that equal to 0. So I'm going to have 2x plus pi over 2 is equal to 0. I'm subtracting pi over 2 from both sides, and I'm going to get 2x is equal to negative pi over 2. And normally I would divide by 2, but instead let's multiply by 1/2, because that might make it look a little bit easier about what I'm doing. Here the 2's will simplify, and I'm left with x. And then negative pi, that's when I multiply my numerators. And then the 2 times the 2 is 4. So I'm going to start at negative pi over 4. To find my end, I'm going to take that 2x plus pi over 2, and I'm going to set it equal to 2 pi. So I'm going to subtract pi over 2 from both sides. And when I do that, this 2 pi is technically 4 pi over 2. So I have a common denominator, and I'm going to get 3 pi over 2 when I subtract. Multiply by the reciprocal or divide by 2, however you want to look at it. I'm going to get x is equal to 3 pi over 4. So my end is going to be 3 pi over 4. And to do a double check, the distance from the start to the end should be this period. So the distance between negative pi over 4 and a positive 3 pi over 4 is 1 pi. So I did do that. Right. So I'm just going to all right, my horizontal shift is whatever my start is. So that's going to be negative pi over 4. Eventually, we're going to think of that as c over b, but we're not there yet. The vertical shift is whatever I'm adding or subtracting on my b value, so in this case it's 0. And my amplitude is the absolute value of that a, so my amplitude is just going to be 3. Okay, it says I'm starting at negative pi over 4. My step is positive pi over 4, so negative pi over 4 plus positive pi over 4 is 0. Then 0 plus pi over 4 will be pi over 4. add another pi over 4, and I get 2 pi over 4, which I'm going to write as pi over 2. And then finally 3 pi over 4. Go up here and see that it's a cosine curve, which means my pattern is going to be 1, 0, negative 1, 0, and 1. That's just something that I'm going to have to memorize. Now for the next column, I'm multiplying by my a, which is 3. And you might want to put that 3 in there. So multiply every number by 3. And finally, the last column is to add d, which in this case means I'm going to add 0, which means that one column is not going to change at all. When I go to the graph, I'm looking at that first column and the last column. Remember, everything else is work in progress. So when I go to do this, you know what, I'm not going to change the scale just so you can get used to like leaving the scale alone. So if this line is pi over 2, then half of that is going to be pi over 4. So each line is 1/4 pi. So I'm going to start at negative pi over 4, which would be here, and I want to be up at 3, 1, 2, 3. Then I'm going to go 0, 0, pi over 4, negative 3, pi over 2, 0, and then 3 pi over 4, 3. And if I were to continue that pattern, like if I were just writing these numbers down and repeating, it goes 3, 0, negative 3, 0, 3. So the next number that I would add, if I kept on going, would be a 0 and negative 3, 0, 3. And I'm going to keep that pattern going. So when I come over here, I'm moving over 1/4. I'm going to hit 0 again, and then negative 3, and then 0 again, and positive 3. And then finally 0 again. I'm going to fill in all my graph papers. So this is going to be my cosine curve. Then I'm going to continue this. So see how I'm at the top? Then I'm going to go to what I call a baseline. I'm just going to keep on counting. That's all I'm doing, I'm counting. So you have to go up, hit the midline, down, hit the midline. And so when you step back, it's not necessarily that the left side looks like the right side, it's just this continuous flow of that cosine curve. Moving on to the next one, I am going to identify my A, my B, my C, my D. So my A in this case is going to be 1/2. That's okay, fractions don't bother us. My B, when I look here, there is no number here that it's in front of the X. So remember that's understood to be 1 because it's multiplication. So my B is going to be 1. My C, remember this is BX minus C. So in this case, I have X minus pi over 2. So the C is that pi over 2. And then my D is whatever I'm adding or subtracting on the outside, which in this case will be negative 1. To find my period, I'm going to take 2 pi, and I'm going to divide it by my B, which in this case is 1. So it's going to stay 2 pi. My step, I'm going to take 2 pi and divide it by 4, which will end up being pi over 2. To find my start, I take what is ever in that parenthesis. So in this case, it's x minus pi over 2, and I set that equal to 0. And when I do that, I add pi over 2 to both sides. And I'm going to get x is equal to pi over 2. So that is my start. To find my end, I take that x minus pi over 2, and I set that equal to 2 pi. But remember that 2 pi is 4 pi over 2, so I have that common denominator. Add pi over 2, add pi over 2, and I end up with x is equal to 5 pi over 2. And that's going to extend past my graph paper because my graph paper is at 2 pi, but I'm going to just leave that. I'm good with that. Horizontal shift, remember, is my start, so this is going to be pi over 2. My vertical shift is whatever my D is, which is going to be negative 1. My amplitude is the absolute value of that A, so it's going to be 1/2. So I said I start at pi over 2, and I'm going up by pi over 2. So 1/2 plus 1/2 is 1. Then 3 pi over 2. 3. 4 pi over 2, which is 2 pi, and then finally 5 pi over 2. It is a sine curve, so that's going to be 0, 1, 0, negative 1, 0. Now I'm going to multiply by my a, so that's still going to be 0, 1 half, 0, negative 1 half, and then 0. And then finally my b is to subtract 1. So this will be negative 1. 1 half minus 1 will be negative 1 half. This will be negative 1. Negative 1 half minus 1 will be a negative 3 halves, and then negative 1. And my scale is good to go. I'm going to just use the markers that I have. So remember, when I go to graph, I am graphing just the first column. Ooh, that's bad color choice. And the last column. Remember, everything in between is just work in progress. So I'm going to graph pi over 2, negative 1. I'm going to graph pi negative 1 half. Pi negative 1 half, so put that there. Then I'm going to graph 3 pi over 2, negative 1. I'm going to graph 2 pi negative 3 pi. So that's negative 1 and a half, so that's to go here. And then if I imagine that I continue, the next one would be negative 1. So about here. So here's my curve. Now I'm going to continue. So the next one, this is my max, this is my baseline. Now I'm going to hit my min. That's every 2 lines, so it's going to go there. I'm going to hit my baseline, or my middle point, whatever you want to call it. And I'm going to go 2 lines over, 2 lines over, 2 lines over. And that is the graph of 1 half sine x minus pi over 2 minus 1. Okay, moving on to the next one. Okay, I'm going to identify my A. My A is going to be, I'm going to write a negative 1 because it's what's there. And then my B is going to be 2. My C, again, remember this is my BX minus C. So 2x minus a negative 1/3 will give me that positive 1/3. So my C is going to be negative 1/3. My D is going to be whatever I'm adding or subtracting on the outside, and I don't see anything, so I'm going to write 0. Remember, if nothing's written and it's multiplication, then it's understood to be 1. And if nothing's written and it's addition or subtraction, it's understood to be 0. To find my period, I'm going to take 2 pi and divide it by that b, which is 2, and I end up with pi. To find my step, I take this new period and I divide it by 4. Then to find my start, I take whatever's inside that parenthesis. So whatever's inside this parenthesis, and I set it equal to 0. So I'm going to take 2x plus pi over 3, and I'm going to set that equal to 0. I kind of put 6 there for a second. Subtract pi over 3 from both sides. And I'm going to have 2x is equal to negative pi over 3. Multiply by 1/2, which is the same thing as dividing by 2. Since I'm dealing with fractions, it's easier to multiply. I'm going to get x is equal to negative pi over 6. That's my start. To find my end, I take that 2x plus pi over 3, and I set that equal to 2 pi. This 2 pi, I want to write with the denominator 3, so I'm going to make it 6 pi over 3. So 2x plus pi over 3. Now I'm going to subtract pi over 3 from both sides, and I get 2x is equal to 5 pi over 3. Then I go to solve x, divide by 2. Don't want to really divide by 2. I'm going to multiply by 1/2 instead. And when I do that, I get x is equal to 5 pi over 6. So this is 5 pi over 6. My horizontal shift is my start, so that's negative pi over 6. My vertical shift is my e, which is 0. My amplitude is the absolute value of that negative 1, which will be 1. To find I said I started at negative pi over 6. And now I'm adding 1/4. So, if you're not a fraction person, which I don't think most of you are, I'm going to bring up my calculator and show you how to do that on a calculator. Give me a second. Set my calculator, I'm good to go. So I am trying to add to this -pi/6. I'm trying to add my step, which is that positive 1/4. So on my calculator, unless you can change everything to 12ths, but I don't know that you guys are actually going to do that. So here we go. That's not what I want. I want the other one. So I'm going to do fraction. And we're starting at -pi/6. So I'm just going to write -1/6. There. And then to that, I'm going to add 1/4. And when I do that, I get 1/12. So when I go here, I'm going to write pi/12. And I'm going to go back to that, and I'm going to add another pi/4. So plus 1/4 again. And when I do that, I get 1/3. So I am going to write pi/3. And then I'm going to add 1/4 again. And I get 7pi/12. And then finally, I'm going to add 1/4 one more time. And I get 5pi/6. And hopefully, and it does, that matches my 5pi/6. It is a cosine curve, so I'm going to start with 1, 0, -1, 0, 1. That's the pattern for cosine. Now I'm going to multiply by my a, which is a -1. So these signs are going to change. The zeros obviously will stay 0. And then I'm going to add my d, which is nothing. This was a -1, and this is added 0. Alright, so I have this -pi/6. This scale is just not going to work. So I can see that I'm going up by, it has 12. So what I might do is I might make my step. Let's say I go here and I want to change the scale. And I don't want to do 12, so I think that would be way too much. But let's say I say that this line is let's say that we make this pi/6, and then this would be 2pi/6, which this is 2pi/6, which would be pi/3. That makes each line 1/12. Does that make sense? Pi/12. So each time I count, it's going to be 1/12. And so that's 1pi/6, 2pi/6. This would be 3pi/6. Which will be pi/2, and then this is 4pi/6, which will be 2pi/3. So, okay, so, oh, that kind of made it short. I'll look at it. So here I'm graphing my first column and my second column. And I forgot to change the scale everywhere. So this would be -pi/6. I'm just skipping down here. This would be -pi/3. We're just going to count, really. We're not going to worry about that. pi/2, and then -2pi/3. So the first one is -pi/6. So that's here, -pi/6, -1. Plot that point. Then I'm going up to pi over 12, which will be 0. And here's pi over 12, which is 0. And if I count lines, I'm going 1, 2, 3 lines. 3 lines makes one step on this. So then pi over 3 would be 1. And I do have pi over 3, 1. And notice again, that's 1, 2, 3 lines. I'm going to make these dots bigger because I put the dots bigger. And then I'm going to do 7 pi over 12, which would be here, 1, 2, 3, and that's going to be 0. And then I do 3 more lines, so 1, 2, 3. So put it down here. So I'm going every 3 lines. So I'm going to count 1, 2, 3 lines, and then I have to decide whether I'm going up or down. Well, this is as low as it gets, so I have to go up to that midline. So I'm going to put a dot here. Now I'm going to count 3 more. So 1, 2, 3, and that is going to go all the way up to 1. And that'll be the graph of my cosine curve. I think counting, you could have changed the scale to something that might have been a little better. But as long as you count and notice that there is an equal distance between these dots, it's up. In this case, it's up. For my graph, it's always 3 lines, which kind of makes sense because this would be 3 pi over 12 is 1/4. So my step is 3 lines. So that's the way you want to think about it. Hope I know it doesn't help. So A, moving on to the next one. A is equal to 2. B is equal to 1/2. C is, remember, it's bx minus c, so 1/2 x minus a negative pi, so that is, oh, it is just minus pi, whoops, minus pi. So my c is pi, and then my d is whatever I'm adding or subtracting on the outside, which would be negative 1. Okay, to find my period, I'm going to take 2 pi, and I'm going to divide it by 1/2. Which is that keep flip switch, so it's going to end up being 4 pi. To find my step, I'm going to take that 4 pi and divide it by 4, so that's going to end up being 1 pi. To find my start, I take whatever's in that parenthesis, so I'm going to take that 1/2 x minus pi, and I'm going to set that equal to 0. So when I do that, I'm going to have 1/2 x is equal to pi. To solve this, I'm going to multiply both sides by 2, and I'm going to get x is equal to 2 pi. So my start is 2 pi. To find my end, I'm going to take 1/2 x minus pi and set that equal to 2 pi. Here I add pi to both sides. I'm going to get 1/2 x is equal to 3 pi. Multiply both sides by 2. And I end up with x is equal to 6 pi. So if I start at 2 pi, and I go up by pi, there's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. I'm going to go up and see that I'm a sine curve, so my pattern will be 0, 1, 0, negative 1, 0. Multiplied by my a now, which is 2, so this is 0, 2, 0, negative 2, 0. Add my d, which is negative 1, so negative 1, 1, negative 1, negative 3, negative 1. Remember, when I go to the graph, I'm just graphing the first column and the last column. Everything else is a work in progress. When I look at the scale, here's the problem. 2 pi, I'm starting here. I'm starting off my graph paper. Now I have choices. I could go back here and say, well, it repeats itself every 4 pi, so I could subtract 2 pi and start at negative 2 pi. But I'm willing to bet that none of you are going to think to do that. So what I'm going to do is I'm going to change the scale, and let's make this 2 pi. It's still not going to fit, but and this would be 4 pi. This would be 2, 4, 6, and then 8 pi. So if I make this line 2 pi, that means each line here is 1 pi. So let's keep on doing that over here. Negative 2 pi, negative 4 pi, negative 6 pi. Now, you may have a different scale than me, and that's fine as long as you did the correct work, and that's one of the things I have to check is that the work is correct. So 2 pi negative 1, 2 pi negative 1, I'm going to put a dot here. 3 pi 1, so 3 pi is here, and now I'm going to 1. 4 pi negative 1, 4 pi negative 1. 5 pi negative 3, 1, 2, 3. Remember, since this is 2 pi, each line is 1 pi, which is what my step is. So every line, I'm going to have a dot. And so that's negative 3, and then 6 pi is negative 1. So here's my first one that I do. Now continuing the pattern, every line I'm making a dot. I'm going to go up here next. Here. Keep on counting here. Well, if I follow here, the next thing I'm going to do is go down and hit that midline again, then go up, hit that midline, every dot. And sometimes I think it's easier for doing every dot because then you don't have to count. You just know that every dot you're putting every line you're putting a dot. What could be easier than that? I wonder. Take trig, I guess. Okay, we love trig. Remember, did you say it while we were doing this video? We love trig. And there's my graph. So I'm going back up, making sure it makes sense, and it looks like it does. I'm happy, and I'm moving on to the next one. So again, identifying my A is 1, my B is 2, my C is whatever I'm subtracting. Well, there's nothing there, so that's going to be 0. And then my D is whatever I'm adding or subtracting on the outside, which is negative 1. So when I go to do this, I'm going to take my period, which is normally 2 pi, divided by the B, which is 2, and I get a period of pi. That means every pi units, the curve is going to start repeating itself. My step is pi over 4. To find my start, I take whatever's in the parentheses, so 2x set equals 0, which means x is just going to equal 0. To find my end, I'm going to take 2x and set that equal to 2 pi, divide both sides by 2, and I get x is equal to 1 pi. 2 pi. My horizontal shift is my c, which in this case is 0. I'll see it b, or my start, however I think about it. And my vertical shift is my d, which is negative 1. My amplitude is 1. So when I start, I'm starting at 0, then pi over 4, because that's my step. So this is 2 pi over 4, which is pi over 2, 3 pi over 4, and then finally 4 pi over 4, which is just pi. It is a cosine curve, so I start at 1, 0, negative 1, 0, and 1. Multiplied by my a, which is 1, so 1, 0, negative 1, 0, 1. And my d, which is negative 1, so this will be 0, negative 1, negative 2, negative 1, 0. So I'm going to leave the graph paper alone. It's fine. If this is pi over 2, then half of that would be pi over 4. And that's my step. So I'm going to make a dot every line again. Remember, I'm graphing just the first column and the last column. Everything else is work in between. So I'm graphing 0, 0. That's easy. I'm graphing pi over 4, negative 1. Pi over 2, negative 2. 3 pi over 4, negative 1. And then finally 4 pi over 4, or pi, and then back to 0. So here is my curve. And now I'm going to continue. Every line has a dot. Every line has a dot. Just continuing that pattern. Just continuing that pattern. And that's my graph. All right, I hope this helps, and we'll see you next time in class.